Modern data scientists are no longer required to just crunch some number and then report a statistic. Instead, we're supposed to interact with databases, web APIs, or some cloud storage. We're also supposed to use AI to find and extract information from large bodies of text. And then we're also supposed to wrap all of this into a nicely formatted document, website, dashboard, or web app. To be fair, this is still the good old data science process. That part hasn't really changed. What has changed is that expectations and challenges at every step of the way kind of got broader due to new technologies and techniques that we can use. So in today's video, let's have a look at what the modern R ecoverse can offer for all of these different challenges. So whether you are a beginner or a seasoned R pro, let's have a look what the R ecosystem has in store for you. So with that said, let's dive in. Now, before we start, let me mention that I have created a PDF guide for you. It contains all of the things I'm going to show you today and much more. There's so much resources in there that I can't cover everything in this video, otherwise it will get too long. Also, throughout this video, there will be links popping up, I don't know, there or there. I always forget at which corner YouTube shows them. But my point is there will be notifications showing up to lead you to different tutorials if you want to dive into a specific topic more deeply. That way you can watch this video to get the lay of the land and then dive into what interests you. So now that we've got this covered, let's start with the basics. If you are new to R or data analysis, there are kind of two things you want to do first. You will want to learn how to do basic transformation steps with data, and you will also want to learn how to create charts and tables. For both of these steps, the beginnings are kind of easy. If you want to learn the basics of data transformation, you don't have to look far, you only have to look for the TIDEViz package that has a suite of tools for data science. And then you can take this data set and chain together a couple of fundamental functions that do very basic things to get the job done. For example, you can select a set of specific columns, create a new column with this data, summarize your data by group, and then sort the findings accordingly. This, in a nutshell, is how data processing can work by chaining together simple steps to get the data you need. Of course, there's more to it, but you can get started with the 6 fundamental functions that power all of this. For the second step, that is creating charts and tables, there are kind of 3 main packages that you need to think about. For charts, there is ggplot, which is part of the TIDEViz, so you already have that. For tables, there's the GT package, and for interactive tables, there is the reactable package. For ggplot, the idea is that you stack together layers of chart elements. You start with a blank canvas, then say that you want to have a layer of points, then you specify how things like the coordinates of the points or the color of the points are supposed to be mapped to the data itself. And then you can specify other settings like size and transparency. And once you do that, you get a chart that shows you what you've just specified. Now, the code for this needs some getting used to, but once you understand the grammar, the logic behind this, it's really smooth to work with, and I have a full guide just for ggplot for you. For the GT package to create tables, the idea is kind of the same. You take a data set, and then you chain together different steps to transform your table. If you have a data set like this, then you can take it and just pass it to the GT function to get a very basic table. And then you can modify things like grouping, and then pass this thing to other functions from GT to, say, modify the column labels or specify specific table headings. So you kind of get the idea. And for interactive tables, you can use reactable, and there the logic is a little bit different. You don't chain together stuff, but instead you put everything into the reactable function. You start with the data set, and then if you execute this, you'll see that you get a table. And it is interactive by default, so that means you can already do basic operations like sorting or paginating through different rows. And then you can, for example, specify column arguments inside of this reactable functions by specifying a list of column definitions for every column that you have in your data set. And that way you could, for instance, change the labels of the columns. So once you understand the fundamental functions to wrangle a bit of data, and also understand the basics of how to create a nice chart or table, then you already have a good fundament to go into different areas of our programming. And from here, there are multiple areas that you can target next. For example, you could go down the data visualization route because it's a kind of fun way to explore more programming and there's lots to discover. There are many data visualization techniques, and both inside of the R and GT ecoverse, there are multiple different packages that extend what the basic package can already do for you. Or a good next step could be to get to know the tool that you use to write in code. If for you that's RStudio, then I have a video that shows you a whole bunch of productivity tricks with RStudio. It's a good idea to get good at the tool that you use for writing code. Just makes you more productive overall. And if you use Positron, which I personally prefer nowadays, then I have a video for you for how to switch from RStudio to Positron or how to get the most productivity tricks out of Positron. And if you want to learn more about data cleaning, a good place to start would be to avoid repetitive code. For example, take a look at this code here that just takes this data set here, selects a couple of columns, runs the same calculation on all of these columns, and then summarizes each column by calculating the mean for each neighborhood that is inside of this data set. And of course, this works, you get a result, but this thing is messy and kind of annoying to write. Instead, you can use so-called tidy select helpers and helper functions like across to automate a whole bunch of these copy and paste things you did before. And that way you get, of course, the same exact result, but it's kind of nice that you don't have to tediously copy and paste a whole lot of stuff. And if you're even going for shorter and conciser code, then you might want to look into the data.table package. This package allows you to make a data frame into a so-called data table. And with this, you can then run this sort of concise code to do the same kind of calculations. Here, this isn't the exact same code as I ran before. It doesn't give you the same results, but you can see how concise the syntax is, and it allows you to do a whole bunch of stuff with a tiny bit of code. And it is also super fast, even on huge data sets. That's the main advantage of data table. But of course, there is some getting used to this kind of notation. But there's also a bit of beauty in this kind of short and concise notation. It's really more about personal preference. And speaking about short and concise, the next time you kind of write a for loop to iterate through, say, a set of CSV files, then you might want to try using functional programming instead. For example, for a bunch of CSV files, you could normally take a for loop and then iterate through all of these files that you have, and then read the CSV files and bind those together into a large data frame. Or you could use a functional programming approach from the per package and simply do the same thing in one line of code. That's super neat, and functional programming, if you haven't unlocked it yet, you should try it out because it helps you so much, run so many calculations in a short and elegant way. Next, let us talk about data storage and retrieval. But before I talk about this, let me mention that if you enjoyed this video, make sure to give this video a thumbs up so that I know that you actually like this kind of content, and also think about subscribing to this channel to also let me know that you enjoy my content and want to see more of it. And of course, this also tells the YouTube algorithm that this content is cool. So thank you for supporting my channel. And now let's get back to data storage and data retrieval. In a lot of scenarios, you won't get a single CSV file or some other file format to run a data analysis on. What you often have, especially if you're working in a larger company, then what you'll have is a database. And with this database, you kind of have to figure out how to connect to it. But the nice thing is that the R ecoverse has a nice set of good helpers for that. For example, if we look back at this code here that just takes a data set that we currently have in R, then run some steps like select, mutate, and so on this data set, then we can easily switch out the data set in this with a database table. That's kind of the nice thing that I want to talk about here, is that you don't really have to learn a whole bunch of more things to work with databases. No, you only have to understand two things. One is you need to connect to your database, and with this connection, you can pick out a specific table, and this is the thing that you can then stick into where your data currently is used, or where you'd normally use a regular data frame. So what you'd usually do is to set up some kind of connection variable using the dbConnect function from the DBI package. There you often fill in things like user credential or IP address of the database. Your IT department will help you find these things. And once you have that connection, you can replace the data set with a table from this connection of a specific name. And then the rest of the code still works the same. I do have 2 videos about this. One is to give you a crash course on how to do these connections and how to work without dplyr code to interact with databases. It's also a bit of a SQL crash course. And then the other video teaches you very common operations that you want to do with a database, but instead using our favorite dplyr syntax here. But of course, at other times, you don't have to work with a database, but instead you might have some cloud storage like AWS S3 that you have to connect to. For that, there is the pins package that allows you to easily connect to these kind of things. And also it even comes with integrated data versioning, that if you override what you currently have inside of this cloud storage, it is still tracked what you had before. And each iteration of this is also saved. So that way you immediately have a nice data versioning mechanism that you can use together with your cloud storage. Alternatively, sometimes you have to get data from the internet by web scraping, say, a table. For that, there is the rvest package that allows you to do just that really easily. And sometimes you have to integrate with web APIs through HTTP requests. And now if all of this sounds gibberish, I mean this web API stuff and the HTTP request, don't worry, it's really more a way of saying you throw some code at some address in the internet, and if you do everything correctly, then this internet address will spit some code back, and this code is usually JSON encoded data. And the nice thing is that there is a package that handles all of this for you. You just have to learn its code, which is really nice because it's also modular like ggplot and GT, where you can iteratively assemble such an HTTP request. For that, I have a really detailed tutorial that shows you how to go from very simple HTTP requests to complicated OAuth flows to interact with any kind of web API you might encounter. And you might wonder, where is this API thing really useful? Well, it is useful in the most hyped topic of them all, namely when you want to work with AIs. And what I mean by AI in this case is large language models. You see, what you in practice often do is you simply take your data and send it to, say, OpenAI or Anthropic Claude or AWS Bedrock or some other AI provider that you have. You take your text data, send it to them, and then you get the data back. And the data you will get back will be the AI response. And just like the Header2 package allows you to write these kind of API requests in general, there are other packages specialized for these LLM calls. And these you can use to interact with AI. For example, the easiest way to get started is to use the mol package. It allows you to simply take a data frame and pass it to AI for a specific task. For example, if we take a look at this data set, it's just a bunch of adjectives like painful, hungry, and so on. And then we could take this data set and then pass it to the LLM sentiment function from the mol package to run a sentiment analysis on this adjective column. And if you run this, you'll get back the same data set, but with an additional column that tells you the sentiment of these adjectives. So what happens in the background is these API calls to some AI, and the response of that AI is taken as a result for your analysis. But the mol package only has a bit of limited support for what AI can do. So that's why you'll probably outgrow it really quickly, but as a starting place for AI stuff, it's kind of cool. But if you want to go further, there's another package that handles all kind of communication with AI, and that is the ellmer package. The ellmer package allows you to create these kind of chat objects with a specific AI vendor. There is, for example, chat OpenAI if you want to chat with OpenAI. Or there is chat Anthropic if you want to chat with an AI model from Anthropic. And so on. I think you kind of get the idea. And once you have such a chat, what you can do is use its chat method to chat with it as if you were typing into the browser with the chat window. And then you'll get back the response into your console. So that in itself is neat, and it allows you to do a whole bunch of stuff. For example, you could also equip a chat with R functions so that you can let an LLM decide how function arguments are supposed to be filled. That's a great way if you can program a regular function for all kinds of different scenarios with different input data. But what you can do is to write an R function for a particular task, and then let the input data go through an LLM to decide, okay, how does this R function need to be applied? And then this R function with the right arguments is run on your computer, and you get more robust results. And here, more robust means that the AI doesn't hallucinate as much because it just to fill in the arguments for this function, and the rest is just regular hard-coded stuff. And it is also more robust in the sense that you kind of can do more with your function because you don't have to take into account every possible scenario of what your input data might look like. You let the LLM put it into a sort of unified format that your function can work with. And another really neat thing that you can do with ellmer is structured data extraction. For example, if we have a PDF like this and you want to extract all of the invoice positions that are listed in this, then what you can do is to extract all of the text from the PDF using something like the PDF tools package. Then you can specify what kind of information you're looking for using functions from the ellmer package to specify the output format. And once you have that, you can create a new chat where you in the system prompt say the task of that AI, and here it would be to extract the information from invoices. And then you can run a structured chat using this chat object to take the text from the PDF and extract all of the information of type that you've just specified. So that's a really neat workflow, and it allows you to do a whole bunch of data extraction and document intelligence operations that you usually wouldn't be able to do without AI. So that's really helpful, but I can totally understand if this was way too fast and it's kind of a lot of steps in between that are missing to understand what's really going on. So that's why, of course, there is a video to this for this particular task as well, just like there is a video for all of the different kind of other things I have shown you here. In any case, more information about this sort of technique you can find in the PDF guide or in the other video. Finally, let's talk about the communication part of the data science process. This video is already getting way too long, so I'll try to make it short. Basically, for most scenarios where you want to generate some document or a website or a dashboard with your data, then you can use the Quarto tool to get the job done. It's a fantastic tool that allows you to mix code and its output with regular text to assemble things like the ones I've just mentioned. So you can create a website from this. If you combine this with parameterized reporting, you can cover a whole bunch of ground for different set of scenarios. So you could take one report template and then generate it for all kinds of different stakeholders so that each stakeholder can only look at his specific data. Or you could use Quarto to generate a dashboard. That's a very specific type of website. Or you could use Quarto to generate a PDF file with your data. In this scenario, I would also encourage you to use types with that. Quarto has this types PDF rendering engine also built into this. And with types, you can create really beautiful PDFs in a really nice way. So that's why you can either use types as a standalone tool if you don't want to use Quarto, or you can mix types and Quarto. For both of these scenarios, I do have videos for that. And if you need some output format from Microsoft Office, like a Word document or a PowerPoint slide deck, then I wouldn't use Quarto because even though it has some support for that, I do think the output options are a bit limited. Instead, I'd use the Officeverse, which comes with a whole bunch of packages that allow you to create Words and PowerPoint slide decks. And in case you want to build a web application, which is also a common thing that we data science nowadays have to do, because we want to let people interact with our data or specify some setting for our AI extraction, for both of these scenarios, a web app can be helpful to handle the interaction with other parts of your team. So if you want to build a web application, then there's no way around RShiny. That's a fantastic package that allows you to build just that, namely web applications. But be warned, this is not a simple topic and it will take you down a web development pathway. So that's why for this last web development part, I have not only one video for you. No, instead I have two full playlists, one for Shiny, one for web development in general from an R perspective. And both of these combined will help you build web apps that get the job done or whatever you need to do with that. So with that, we have covered a whole bunch of ground inside of the R Ecoverse. Feel free to let me know if I forgot something. Remember that there is a whole bunch of tutorials that you can watch to take a deep dive into a specific topic. And of course, there's the PDF guide that you can download and then check out to get an overview over all the tutorials for all the different kind of topics I have. So with that said, I say thank you for watching and I'll see you next time.